This is a SpaceX interview question. Can you pass it? Let's figure it out together. Two water tanks drain through identical holes at the bottom. One tank is a cylinder, the other is a cone. The tanks have the same height and the same top radius. Which one empties faster? Okay, same hole, same height, same top radius. The pressure at every height is the same, given by the hydrostatic pressure, so the flow rate is also the same. So both tanks empty at the same time. Right? Scrap it. Bernoulli's equation gives us V equals the square root of 2GeH. Same height, same velocity, that part is true. The real question is how much water is there left to drain at a given height? In a cylinder, every drop in water height corresponds to the same amount of water drained. It is uniform all the way down. In a cone, that is not the case. The top holds a lot of water, but as you go down, there is less and less water left to drain. Near the bottom, there's almost nothing left. So even though the speed changes the same way in both tanks, the cone has less water to push out as it empties. That is the difference. In fact, the math says that the cone empties about 5 times faster. For the cylinder, the area A of H is constant with H and equals pi r squared. For the cone, however, A of H is a function of H. The rate at which the volume of water drops equals the outflow rate through the hole. Rearranging and integrating both from full height H down to 0 gives us the drain time for each tank, and their ratio is 1/5. The cone drains 5 times faster not because the water flows out faster, but because there's less and less water left to drain as time goes by. Here's what SpaceX is looking for. Clear first principles applied correctly. Not gut instinct, not memorization.